that this is for the first time she is going to organize a different type of student seminar where the senior students have been entrusted to train the juniors, and the juniors will represent, and it will be a very easy presentations in the sense that all the students will be able to understand. And in this respect, I can remember only one incident. I used to go to various colleges to act as a chief guest. Now in Samilani College, which is very near to our Heritage College, I went there in a physics seminar and I was supposed to act as a chief guest. And all the students and teachers of physics department were present there. And when I was asked to convey my greetings and I am to give the lectures as a chief guest, I started in this fashion that I do not know why I should be invited to act as a chief guest, because I am worthless. They couldn't understand. A principal of such a senior level declares himself as worthless. I then cleared it in Bengali. Physics means Padartha Vidya. So all the students of physics are worthy enough. But I don't belong to physics. I am a student of economics, so I am Apadartha. That means worthless. In this way, I tried to explain. Actually, this is the subject which I like most. I believe that the students of physics are really very good. Otherwise, they would have scared to select this particular subject as their honors course. They have a bright future, and I believe that all my beloved students will come up with flying color in the near future. If you are ready to comply with the instructions given by your professors, including your head of the department, I believe that there is no force in the world which can stand in the way of your success. Success is a must. And we the teachers always say, Sarvatra Jayaman Nichet Putrat Shishat Parajayam. What does it mean? This means in Bengali, Shob Jaygaye Joy Kamuna Koro, Putra ebong Shishyer Kache Parajoy Gauraber. Now, if it is found that after the proper training, if our students can prove themselves that they are even better than their teachers, we shall feel proud of all of you. And I also believe that the person behind it is your HOD, because to me, she is the best teacher. Now, who is the best teacher? I always try to explain the definition of best teacher in this way, that a best teacher is he or she who can motivate, who can invite, who can induce, who can encourage his students by way of making him or her understand of the fact that the students are full of possibilities. Yes, you do have immense possibilities. She believed in your capabilities, and so she took the initiative to organize such a seminar. And I believe that this August Awayday will be one of the finest seminars I have ever heard. And I believe that all the students present here interact. I also take the opportunity to welcome all the students of other colleges, all the teachers, the professors of other colleges who joined us today, who readily responded to the request of our HOD, Dr. Madhubrata Bhattacharya. So no word is sufficient to appreciate Dr. Madhubrata Bhattacharya for taking such initiative. I have a firm faith. I express my heartfelt thanks and gratitude to Dr. Bhattacharya, with the expectation that in the near future, she will again encourage her students in such a way that the students will get incentive. They will be taking initiative to organize and participate actively in such seminars. So without wasting your time, I don't like to continue anymore. I once again thank you. I once again congratulate you. And above all, being your principal, I once again bless you from the core of my heart. And I believe that my students will come off with flying color in the near future. And on that very day, our joy will know no bounds when we'll come to know that our students are the assets, are the best citizens of our country. Thank you very much. Thank you all.
Thank you so much, sir. Now I would like to request our HOD, Dr. Madhubrata Bhattacharya, to share something with us.
Respected Principal, the Heritage College, my dear colleagues and beloved students, good evening to all. On behalf of the Heritage College, I feel privileged to welcome you all in the webinar August Awayday, organized by the Department of Physics. This is organized by the students of my department. Actually, today in this seminar, I have done nothing. We, the faculty members of the department, have done nothing. Yes, the idea was mine, but it was Vishal who accepted first without any question. It was Protoy who motivated the junior students and prepared them. It was Manoj who was always with them. Thank you, mentors, for all you have done. August Awayday would not be possible without your support. By the way, Vishal and Protoy is our outgoing third year students and Manush is in semester 5 now. And now, today's speakers. Same three students, you are simply amazing. I wish you all the best for today and I know that you are going to make me proud again. Thank you.
Thank you so much, ma'am. That was indeed a very warm introduction to the topic. Without further delay, I would like to request you to switch off your mics for better voice clarity during this presentation, and the audience is also requested to not present their screens. I repeat, I would like you request you to switch off your mics for better voice clarity during the presentation, and you're requested to not present your screens. I hope you enjoy the session and find it highly engaging and fruitful. So the first topic for the day is magnets. So all of us present here, we know what magnets are. We have played with magnets when we were younger. So we know if we bring two unlike poles of a magnet close to each other, they attract. And if we flip over one of those magnets and bring two like poles together, they repel each other. We feel this repelling force in our hand. That sounds amazing, right? So now what if I told you that these very same magnets, stronger and more sophisticated ones, can be used to lift and move trains that weigh as much as 40 tons and even more? Sounds incredible. So presenting to you our first team of this session, Team Faraday, who are going to enlighten us with some baffling details about electromagnetic induction and its application.
Good evening, everyone. This is Shuchi Shubhra Dottoray from Team Faraday, along with my teammates Sanjukta Dotto, Shayok Roy, Devarga Roy, are in front of you to brief you all about our topic, electromagnetic induction and its application, a journey from its beginning to ultimatum. We basically divided our topic into four phases. Phase 1 deals with its introduction into the world. Phase 2 deals with its daily life application. Phase 3 deals with a gigantic jump in development of technology in this field, that is in magnetic tech. Phase 4 deals with its ultimate stage of development till now, that is the Hyperloop. And at the end of our presentation, we, Team Faraday, would like to show you some of our raw ideas for the betterment of the society, which we think is related with this topic. So for phase 1 and phase 2, I would like to call Sanjukta Dotto to brief you all about it. So Sanjukta, over to you.
Good evening, one and all. I, Sanjukta Datta of Team Faraday, will be introducing you all to the concept of electromagnetic induction, its historical background, and the daily life applications. So, starting with the introduction, we all have heard about the term magnetic induction, right? So, any idea about what is magnetic induction? Well, magnetic induction is a phenomenon in which a magnetic field is induced by electric current. So naturally, a question arises now that can a magnetic field produce an electric current too? So now Faraday was the one who answered this question, where he experimentally showed that a changing magnetic flux in a closed circuit induces electric current. This phenomenon was known as electromagnetic induction. So in brief, we can say electromagnetic induction is the production of an electromotive force across an electric conductor in a changing magnetic field. Now coming to the basic historical background behind the establishment of this phenomenon. So Oersted was a Danish physicist who explored the relationship between electric current and magnetism through his experiment in which when a current was switched on in a circuit, it made a compass needle turn at a right angle to the wire. So from here it was concluded that the current had produced a magnetic field which was strong enough to make the compass needle turn. In 1831, Faraday, through a series of experiments, concluded two things. Firstly, that in a closed circuit, the changing magnetic field induces a current, and secondly, the direction of this induced current is opposite to the direction of the magnetic field. Now, the second law was known as Lenz's law. Now, we can also determine the direction using Fleming's right-hand rule. Now, coming to the daily life applications of electromagnetic induction. So, we all have seen generators in many multi-storied buildings or in many occasions, right? So, what purpose does this generator serve? Well, generator is an electrical device that converts mechanical energy into electrical energy in the form of alternating EMF or alternating current. This generator works on the principle of electromagnetic induction. Now next, after that, we have electromagnetic flow meters. Flow meters are basically transducers that measures fluid flow by the voltage induced across the liquid by its flow through a magnetic field. As you can see in this diagram, it contains electromagnetic coil that generates a magnetic field, and there are electrodes present that captures the electromotive force. Then there are transformers. Transformers are basically passive electrical device that transfers electrical energy from one circuit to another through the process of electromagnetic induction. They are commonly used to step up or step down the voltage between the circuits. Now coming to a large-scale application of electromagnetic induction, that is the maglev technology. We all must have been familiar with this term maglev technology. So I would request Shuchi Shubhra Roy to come and introduce us to a greater details of this maglev technology. Thank you, everyone.
Thank you, Sanjukta. So this is Shuchi Shubhra again in front of you to discuss a pastry, that is a case study on maglev tech. Now the question that arises is what actually maglev is. What is this word? Well, maglev is a combination of two different words, that is magnetic plus levitation. In definition wise, if you want to understand that, then any body, mass or object which is being raised up or gets floated up by means of magnetic power is simply called as magnetic levitation, and hence the word maglev. Now why actually are we talking about maglev? Why not any other normal trains? Well, here are the reasons why. It consumes less energy, obviously, as it doesn't use any external source like thermal energy, etc. It requires no engine. Why it requires no engine? Because for the motion of the vehicle, it is totally dependent on the process of propulsion, on which also we will be discussing further. It moves way faster than normal trains. As we all know, the average speed of Indian railways is around 130 to 150 kmph. But on the other hand, maglev has a very high speed ranging from 550 to 600 kmph. It is a lot, right? They are incompatible with existing railway lines. That is, they use a specialized railway tracks called as guideways, on which also we will be discussing further. The initial establishment cost is very high, but if you want to think that in a long run process, it is way far cheaper and we can say it is way far beneficial for us. It effectively reduces pollution as they emit no harmful gas in the environment. Now moving on to the next slide. What actually magnetic levitation, or you can say suspension, is and its basic principles. What actually magnetic levitation or suspension is? It is a method by which an object is being suspended with no support other than magnetic field. What are its Principles. Principles, gravitational and any other external opposing factors are being counteracted by the magnetic pressure. Magnetic field also plays an important role here. What actually magnetic field is? Magnetic field is a field of force produced by a magnetized object or a particle or by a changing electrical field. Magnetic pressure is also an important point here. What actually magnetic pressure is? Magnetic pressure is the pressure that is associated with magnetic field. Moving on to the next slide. The question that next arises is how maglev is able to work in a very high efficiency. Well, if I want to answer that in a very short and in an appropriate way, I would like to put 3 points here. Point 1, levitation. Point 2, propulsion. Point 3, lateral guidance are the basic reason why it is doing so. Now, what actually levitation is? Levitation is the process by virtue of which the train is being levitated up or being raised up to a certain height due to continuous repulsion of the like poles present on the downward part of the vehicle and the upward part of the guideway. What actually propulsion is? Propulsion is the process by virtue of which the train moves in the forward direction due to the continuous attraction and repulsion of the magnetic poles present on the sideways of the guideway along with the walls of the train. In short, what propulsion actually wants to tell us? Like poles repels and pushes the train forward. Unlike poles attracts and pulls the train forward. So ultimately, the resultant motion of the train is along forward direction. What actually lateral guidance is now? Lateral guidance is the process through which the train is being able to maintain stability from both the side of the railway track. And the third diagram in this slide, you can see, is the schematic diagram where we have tried to show the direction of these three basic laws. Levitation is being levitating the train in the upward direction. Propulsion is helping the train to move in the forward direction. Lateral guidance is helping the train to maintain stability from both the side of the railway tracks, that is the guideway. Now, moving on to the next slide. What are the basic types of maglev technologies? Well, basically there are two types of maglev techs. That is, number 1, electromagnetic suspension, EMS. Number 2, electrodynamic suspension, EDS. Now, during the earliest approach of maglev tech, EMS was introduced. Now, what actually EMS, that is electromagnetic suspension, is? Electromagnetic suspension is a process where the lower part of the vehicle and the lower part of the guideway uses attractive magnets to levitate the train in the upward direction. But at the same time, they are also having some contact with the guideways. The daily life application of this principle is the current day bullet trains, which have an average speed around 300 to 400 kmph. Now, after further development and update in this field, electrodynamic suspension comes into play. What actually electrodynamic suspension is? Well, it is a process where we use repulsive magnets directly to levitate the train in the upward direction from the track. Since it has no connection with the track, that's why they can attain a very high speed in a very short range of time. The basic application of this principle, EDS, is the current day maglev trains, which have an average speed of 550 to 600 kmph, as I mentioned you earlier. Now this brings the end of phase 3 maglev tech. Now for the most updated version till now on this topic, that is the Hyperloop phase 4, I would like to call Shayok Roy to brief you all about it. So Shayok, over to you.
Thank you, Shuchi Shubhra. Good evening, everyone. I am Shai Fry. I'm here to say a few words about Hyperloop. So we'll start with a brief introduction about Hyperloop. Now, what's an Hyperloop? Hyperloop is a modernized form of bulk transportation whose idea was first proposed by an open source vector design from a joint team of SpaceX and Tesla. Now, in 2012, Elon Musk first mentioned about Hyperloop, and his main idea incorporated a giant low pressurized tube in which pressurized capsules ride on the air bearings generally driven by induction motors. So here a general question arises that why we are preferring Hyperloop over maglev train, means what's the use of it? So as many of us can think that Hyperloop is just a modified version of maglev train and we are just implementing a tunnel through which the train moves. But no, basically when the train moves, the operating tunnels remove the air from it. and hence reduces the air friction. So so hyperloops are much faster than maglev trains. Now we will move forward to its construction and designing part. So Musk described Hyperloop as a cross between supersonic jet, a railgun, and an air hockey table. By electrodynamics principle, the railgun accelerates projectile and helps to gain supersonic speed rapidly. And the air table acts as a cushion for the objects to move with less friction. But what is the source of energy? What will accelerate the Hyperloop pods? So in this matter, Hyperloop also focuses on power consumption. Solar panels are mounted along its track, which generates energy and maintain its speed. Here's a small diagram you can see. It depicts the design of Hyperloop generally proposed by Elon Musk. So moving on to its working mainly consists of three parts. That is operating tunnels, Hyperloop pods, and the solar panels placed above the roof of the tunnel. So as mentioned earlier, this operating tunnels reduces the friction and helps to gain speed rapidly. Now Hyperloop pods are the containers which carries the passenger. I guess everyone has seen an air hockey game, right? So these pods are just like the puck of an air hockey table, which are held above the ground by a layer of air and helps the train to glide. And the solar panels that were placed above the roof of the tunnel helps to remove the air and also to propel the pods. In the next slide, you can see some advantages and disadvantages of Hyperloop. We have already discussed about some of its advantages, like it ensures fast transportation. Its average speed is around 600 mph, which is more than a double speed of maglev train. It is fast, efficient, and cheaper to operate. And it also focuses on low power consumption since solar energy is used. Now, as the cost of transportation is reduced, it also promotes economic growth. Now, on the other hand, some of its disadvantages are: it is prone to power breakdown, terror attacks, and earthquakes, so it's difficult to maintain. Its construction and designing is also a matter of high budget. Now, lastly, it is prone to rapid decompression. And now in the next slide, you can see the basic financing structure and cost minimalization of Hyperloop project. And this brings an end to my topic. And now I would like to call our next speaker, Devargo, to discuss about some of our raw ideas. Thank you.
Thank you, Shayok. So good evening, everyone. Now I would like to share some of our raw ideas that we made based on these theoretical studies. First of all our raw ideas to introduction of the maglev technology in our day-to-day roads. We call our new technology maglev car. It will be working based on the principle of electrodynamic suspension. And again, like the cars now, instead of the wheels, the car will be levitated up from the ground using repulsion. And the theory shows that using special kinds of road with electrical circuit, it is possible to do so. The basic working principle of maglev cars are not too different from that of the maglev trains. Besides, there is a little difference that the specialized electrical roads, which are known as the guideways, in case of the maglev cars, the guideways would be a bit smaller than that of the maglev trains, because here the size factor comes into play. The maglev car will be attain its velocity due to propulsion and maintain its balance on the tracks using the processes like levitation and guidances. Here you can see my friends made a specialized design of road where they have made an beautiful illustration, the diagram showing the mechanism of electrodynamic suspension on the cars. Here you can see the conducting strips will be act as electromagnets, which will cause the repulsion and cause the car to levitate. The blue coils are repulsion coils, which will cause the propulsion of the train, and the train can attain its velocity and move forward. And the red coils are guidance coils, which will be actually guiding the car so that it doesn't get deflected in the wrong way. So the beneficial effects of the maglev car are as same as that of the train, and besides it has some additional benefits like in the introduction of maglev cars in the society will have a better network and well-managed system of traffic. For the maglev cars cannot brake immediately. So my friends again made an beautiful illustration where he shows the simultaneous working of footpaths and the roads in the case of maglev car technology. And here he have shown footbridges connecting from one side of the road to another. In this way, the people will be bound to follow the traffic rules because of their own safety. Now, this will also help in a to and fro movement of the world from here and there in a very fast way. So this actually brings the end of my discussion, and on behalf of my team, I would like to end the presentation here. We will eagerly looking out for some question if you have. Thank you.
Thank you so much, Team Faraday. So I can see that we have a lot of questions for you in the chat box. So we have a question from Pratiksha Roy. How is the maglev train able to attain such high speed within a short time? So do we have an answer for that?
Okay, so how maglev train is able to attain high speed in a very short range of time? As the current day maglev is based on the principle of electrodynamic suspension (EDS), the train is being levitated up directly with respect to the repulsive magnets. Okay, so there is no connection actually with the guide way, that is the ground. So since they have a connection with the ground, so ground friction, I'm neglecting the air friction here, the ground friction have no role to play here. And we all know the friction plays an important role in opposing any sort of motion. So since there is no friction working here, the train is being able to attain a very high speed in a very short range of time. I hope you got your answer. Thank you.
Thank you so much. I think we can take another question. So the question is from Swastika Chakraborty. How is Hyperloop able to reduce air friction? So enlighten us with the answer.
So actually, in the Hyperloop, there are solar panels that were placed above the roof of the tunnel. These solar panels were there to generate electricity, which actually uh, remove the air inside the tunnel. That's why it is much faster.
Thank you so much, Team Faraday. With regards to what they have already said, I must say that I feel very proud as an Indian to tell you that the Maharashtra government gave the final nod for constructing a Hyperloop track between Mumbai and Pune. It is expected to reduce the 3.5-hour travel time between the two cities to just 35 minutes. This is truly a historical milestone for India, making us the first country in the world to do active research on the brand new Hyperloop tech. So, you know that physics is a science of many facets. So, while some physicists are trying to make faster trains, some indulge simply in the joys of how the nature works. So, they often start off with very simple questions like why did the ripe apple fall from the tree and the birds they just flew off? So we all know that the ripe apple fell from the tree because of gravity. But what is actually gravity? So Newton told us that gravity is some sort of force that pulls everything that is present on the earth downwards towards itself. And his theory was so successful that it went unchallenged for over 200 years. And then Einstein came in and he totally changed the concept of gravity. So, what are the differences between these two theories? Where is the debate? Is one of them wrong? So, let's hear this from the members of Team Hawking to elaborate on the topic Newton versus Einstein.
Good evening to our respective principal, teachers, and to all my audience. Today, we are going to discuss on the topic gravity. This is Munigono Shah from Team Hawkins along with Priyanshu Khemka, Rakhi Jana, and Raj Aryan Roy. We all know around 300 years ago, Newton discovered the law of gravitation, which is in still active use. But do you know Newton has been hiding an embarrassing secret from all of us? He actually didn't know how gravity really worked. It was Einstein who later gave us a clear idea how gravity works. Now, let us see how Newton discovered the idea of gravity. Once upon a time, Newton was sitting under a tree and suddenly he saw an apple fell down from the tree. He was confused. Why did the apple fell down from the tree? I mean, why did it go up in the air? This created a curiosity in him, and this curiosity led him to do a lot of hard work, a lot of study and experiments. And finally, in 1687, he gave us the law of gravitation. Now let us see why the Newton's law of gravitation is significant. It encapsulates the idea that there is a force of attraction between two masses in the universe and how strong that force of attraction is. He formulated that the gravitational force is directly proportional to the product of masses and inversely proportional to the square of distance between them. The only thing which remains uncalculated was the capital G, that is the gravitational constant, which was later calculated by Henry Cavendish in 1736. Now, I would request Rakhi to please carry forward the topic.
Thank you so much, Manikarna. Now, as Manikarna said, that according to Newton, gravity is a force which tries to pull two objects towards each other. So there's no doubt that Isaac Newton was a great scientist. It is just because of him that today we know about gravity and we all are discussing about gravity right now, isn't it? But do you know that there was someone who completely changed the definition of gravity with the theory of general relativity? Well, I know that you all are quite curious to know about this term, general theory of relativity. But before that, I would like to tell you a very short story which Einstein himself termed as his happiest thinking. So it was when Einstein was working as a patent clerk, one day he saw a window washer on a ladder. And this made Einstein think that what will happen if the window washer met the ground? He himself put he put himself in the window washer's perspective, and he realized that if he was falling, gravity will be the only force acting on him. He would be accelerating towards the ground, and since the ground will not be pushing up on his body, so he will feel no weight. So with no wind resistance, he will be in a free fall, and this will be no different than being weightless in space. So, in a way, gravity and acceleration were different ways to define the same thing. And the way to connect gravity with the theory of relativity was through the idea of acceleration. And this is what principle of equivalence was. So now let me explain you with a very short and easy example. So suppose there is a man who is holding an apple, and if he drops the apple, now if you're on Earth, so you will feel that you will find that the apple falls under gravity because gravity is pulling it downwards. But if you perform the same thing on outer space, on a spaceship which is accelerating in an upward direction at 9.8 meter per second square, which you know is exactly same as the gravitational acceleration on Earth. So now you'll ask me that, yeah, on a space there is no gravity, so the apple will float. Well, that's correct. The apple will remain at its same position, but since the rocket is moving in an upward direction, so there will be a time at which the apple will meet the ground. And this is how he explained the principle of equivalence. So he realized and he thought that if there was a way to tell the difference. So now he think and he realized that if he took a flashlight or a laser beam on a spaceship, which is again accelerating in an upward direction at 9.8 meter per second square. So if he pointed from one side of the room to the other, so he found that the light beam bends downward. Now you'll ask me why. The reason is because the spaceship is moving in upward direction. Now, if we perform the same thing on Earth, you'll find that the light goes straight. But here the problems come. Einstein thought that how could this be? Because this is violating the principle of equivalence, as the acceleration of the spaceship is no different than the room under the influence of gravity. So then Einstein come to a conclusion that the light beam gets bent in the presence of gravitation field. At first, it seems quite strange because we all know that light travels, light is massless. We all know that light is massless. Then how can a massless things get affected in the presence of gravitation field? So Einstein hypothesized that maybe gravity is somehow creating a curvature of space itself because of the presence of mass and energy, so that the shortest distance that the light can travel is a curved path, as you can see in this diagram. Then with the help of Riemannian geometry, Einstein gave his famous field equation, which is known as Einstein field equation. So now let's come to the most important topic, which is known as the general relativity. Well, Einstein said that gravity is not a force, but he explained it as a distortion of space-time. Now you'll ask me how? Well, for example, place a heavy iron ball at the center of a trampoline. Now imagine that the trampoline to be a space fabric. So the body warps and curves the trampoline fabric because of its mass and weight. Now place a small marble on the trampoline surface and observe that as it travels along a curved path, but at the same time a locally linear path towards a heavier object. Now this is the way the gravity works in universe. So now you have to imagine that how this was different than the status quo of the time, which was Newtonian space and time, which presumed that time was fixed, space was fixed, and gravity is a mysterious force that could act as a distance between massive objects to another without touching it. So in this model, gravity did not affect the underlying space and time, but it acted within it. But on the other hand, Einstein said that no, gravity is not a force, but it's something that emerges from the interaction of space and time, space and massive objects. Now, I would like to welcome Raj, who will elaborate more on this topic. Thank you so much.
Well, thank you so much, Rakhi. I hope that I'm audible. I hope that now everyone has a slight idea about the distinction between what Newton said and what Einstein wanted to say. So let's now talk about planets. The orbits of the planets could now be explained not by some kind of force that acts at a distance, but rather like an interaction that takes place locally with mass or energy and the space around it. Well, however, in order for Einstein's theory to be actually correct, this particular his particular theory have to be tested. This particular test came in form of Mercury. Mercury, we all know, the closest planet to the sun, the smallest planet actually. We all know that all the planets revolve around the sun in an ellipse. Okay, but Mercury's orbit had been a mystery for decades. You know why? Because Mercury's orbit had something known as the precession. What is a precession? It essentially means that its ellipse never closes. The point of the orbit that was the farthest from the sun advances a little bit every time Mercury goes around it. Well, it is as if the ellipse itself is revolving around the sun. So no one could actually figure this out with whatever Newton Baba said. But when Einstein actually applied his theory to this problem, he actually found out the exact precision that Mercury has. Finally, a theory that matched with the observation, which had been a mystery for decades. Well, it was only after 4 years that when a team led by English astronomer Arthur Eddington in 1919 photographed the stars near the sun during a solar eclipse. Well, if Einstein was right, can you please change the slide? Yeah, so if Einstein was right, then the position of the stars near the sun would appear different than predicted location based on where they should be as seen at night. Well, as you can see in the picture, this would happen because as light passes near the sun, it should be bent by the curvature of space due to gravity. Well, and guess what? That's exactly what he found out. giving a thumbs up to Einstein and kudos to Einstein. Well, now you might ask that Raj, fine, I get this space curvature thingy and it's called space time. But how does time enter into the picture? Even if you take the example of a trampoline, then the space around the trampoline is getting bent if you're putting some heavy object around it. How is time actually entering the picture? Well, this is where Einstein's very famous theory, I hope you all have heard about it, the special theory of relativity comes in. Well, the essential presumption of this theory is ki, the speed of light, it always moves in the same speed, regardless of the perspective of the reference frame, be it an accelerating reference frame or a resting reference frame. So, if this is the case, that it means the speed of the light in presence of gravity will be the same as its speed is in empty space, right? So, speed equals distance over time. S equals d by t. We all know this, bachpan se padhte aa rahe hain, but the distance traveled by the beam of light in a gravitational field is longer due to the curvature of space. So, in order for the speed of light to be constant, time itself must pass slower in the gravitational field relative to time in empty space. So, in other words, time increases proportionally with the curvature of the space near a gravitational field compared to an empty space. Why is this? This is because the speed of light had to be same in both the reference frame. So this is why time is actually considered distorted by gravity along with space. I hope it's pretty clear. So it's actually nothing but just part of the same fabric we know as space-time. So this has a very massive implication. This implies that if an observer experiencing no gravity at all sees the clock in a gravitational field running slower, this means that the clocks on Earth run slightly slower than the clocks in the International Space Stations. Well, these effects are confirmed by many enormous experiments, and it is also taken into account in order to keep the clocks of the GPS satellite in sync with the clocks on Earth. So I would like to carry forward this discussion. In 1905, when Einstein was actually working with light, so he had no idea that his works will lead him to actually square off with Newton, like a fight, like a versus with Newton. So this is when Einstein published an idea that the velocity of light has a particular cosmic speed limit. Well, to be precise, it is 299,792,458 meter per second. This speed is something that nothing in the universe can get accelerated to or beyond it. So let's understand what I mean with an example. It's a pretty interesting example, so please listen carefully. Let's create a cosmic catastrophe. Okay, let's imagine that all of a sudden, without any warning, our own beloved sun vaporizes and completely disappears. Now, according to Newton, he predicts that with the destruction of sun, the planets revolving around the sun will immediately fly out of their orbit, cleaning off into the blank space. Well, not essentially blank, but yeah, still the space, and we will all die. Sure, pretty smooth. If someone is new to physics, it will be like not a big, huge problem for anyone who's new to the subject. But any problem with it? Well, yes, Einstein saw a very big problem with this. This particular problem arose with his work with light. So Einstein knew that nothing can travel faster than light, and also that light doesn't travel instantaneously. Okay, like it takes, in fact, it actually takes approximately 8 minutes for the sun rays to reach the Earth, traveling the 93 million miles. And since nothing can move faster than light, not even gravity can move faster than light, then how could the Earth be released from the orbit before the darkness resulting from the sun's disappearance reached our eye? Well, for Einstein, anything outrunning light was pretty offensive. He took that as an offense. So Einstein was like, no, Newton, you're completely wrong. Let's just change the picture of gravity, whatever we thought. And he actually came up with a new picture of gravity where it doesn't exceed the cosmic speed limit. Well, with his discovery of space and time as a four-dimensional fabric of space-time, Einstein said the planets are not kept in an orbit, not because the sun is grabbing them instantaneously and like pulling them with a string or something like that. It is simply because the planets follow curves. Okay, curves that are caused by the presence of sun in the space. So with this new understanding of gravity, let's just rerun the cosmic catastrophe, shall we? So let's just see what happens now if the sun disappears. So the gravitational disturbance, the word disturbance is pretty important. That results that result will form a gravitational wave. Okay, so this particular gravitational wave, we can derive an analogy of this as suppose you throw a stone in a pond of water. So you will see ripples, right? So that ripples of the water can be compared to the gravitational wave that we are talking here. So this means that we wouldn't feel any change in the orbit around the sun until this particular wave reached the Earth. And of course, we will die in this scenario also. Moreover, Einstein actually calculated this particular ripple of the wave is exactly same as the speed of light. So with this, Einstein actually said the word that no, gravity is not a force, but it is actually a geometry, and which is very well explained in his theory of general theory of relativity. Now let's just look upon some conclusions that we have drawn from this whole discussion. So according to Newton, he said that gravity is a force that is experienced between two objects solely because they have some mass. It's solely because of the virtue of mass. And he said that this particular force is a pull. The two objects are pulling each other, and also that this is instantaneous, and it no one will get affected no matter the how far they are from anything, and the gravity will remain constant for everyone. And he said that no matter what the charge is or the chemical composition is, it doesn't matter, it just depends on the mass. But Einstein came later, and he said that no, Newton, you are completely wrong. It is not a force, it is a geometry, and precisely a curvature in the four-dimensional space-time fabric, which is proportional to the object's mass. Objects with more mass will bend the fabric more and push the objects in the field more towards it. And according to him, it's a push. It is not a pull. And also, it is not always attractive, and it doesn't work instantaneously. And of course, it doesn't have an infinite range. Well, with that, I would like to say a warm thank you to all of you for being such a great audience. And as Stephen Hawking says, because there is such a law known as gravity, the universe can and will create itself from nothing. Well, that's for some other day to discuss. For now, thank you for being such a warm audience and have a good evening.
Thank you so much. It seems that we don't have any question for you in the chat box. So if any of you have any question, please feel free to post them. The team will address those questions later. So that was a remarkable presentation. Physics is a dynamic field, and it has moved on beyond the now a century-old debate of Newton versus Einstein. However, Einstein's theory is not complete. There are some controversies, and also it is not consistent with quantum mechanics. Now, perhaps we'll have a next Einstein who will be able to answer why it is inconsistent with quantum mechanics. But nevertheless, what is quantum mechanics? It is just a description of a microscopic phenomenon. But would you be startled if I told you that quantum mechanics play a very important role in dreaming? So all of us present here, we dream at night while sleeping. I believe personally that dreams are one of the most fascinating parts of human experience. However, how is quantum mechanics connected to dreaming? What is the science behind dreaming? So this will be explained by our next team, Team Nishio Kapoor.
Well, a very good evening, everyone, and thank you, Samriddhi. I am Ankon Bose for third sem physics department, Heritage College. I would be streaming for the group Nishio Kaku. So I would kindly request every one of you to pin my presentation. My group mates are Tanaya Siddhant, Shruti Chakraborty, Disha Roy, and me, Ankon. Our topic for the day is Somnium Scientia, which is science behind dreams. And our first speaker of the eve is Tanaya Siddhanto. And you may take the lead.
Where is the slide? Can you please presenting the slide, Ankon? Yes. Thank you. Very good evening to all of you. I am Tanaya Siddhanto from Semester 3 Civics Department of the Heritage College, Kolkata. Today, I am going to explain about the exclusive message of the science behind dreams. So, I think we all are habituated with dreaming. Suppose we are dreaming of winning any race or something else, and at the sleeping stage, we can go anywhere through our dreams. But can we know the mystic relation between the dreams and the science? If we try to know, we should know what the dreams really are. So, dreams are a random flow of images, ideas, emotions, and sensations that occur in almost every mind. And when we are in subconscious or partly unconscious state, in fact, it is a very regular phenomenon that occur in almost every mind. That's it. But what has haunted the minds of great scientists for the past 100 years? To integrate the dreaming phenomena with the rest of the science is the fundamental principle of mind. That is, unconscious events are not observable. Now, what kind of scientific principle is this? That there are certain events which cannot be observed. Well, there is only one principle in all science, and that is the principle of quantum wave function that explains science behind unconscious state. Well, you might be thinking, what is this? Quantum wave? Quantum wave is just like any other wave, which is shown on the screen. Please repeat again, previous one, yes. And which is shown on the screen, the nature of these waves defined by the famous Schrodinger's wave equation, which is also shown on the screen. Okay, so now, according to superposition principle of quantum mechanics, wave functions can be added together or multiplied by a complex function to form a new wave function, defining a new wave. As quantum wave is a superposition of possibilities where only one possibility can be observed at a fixed time. We can obtain the other possibility as well by observing the same wave function over and over again. And as a result, we will be able to determine the frequency occurrence of each one. Now, everything that we observe arises out from the possibilities of quantum wave function. So now, the part of the storyline here that our dreams are also related with our consciousness too. Here, consciousness arising out from the unconscious is a very same process as the process of observation of wave function. This leads into an inescapable conclusion that unconscious is the wave function and consciousness is what we call reality. But the events of the unconscious are not less real than the events of the consciousness. So you might be thinking, what is conscious, unconscious minds are? Here, consciousness is a perspective, rather a way of seeing. If we take any kind of example which is shown on the screen, it is like a tip of an iceberg, which is held up on a buoyancy of a vast ocean. Here, the tip of the iceberg is the consciousness, and the part which is submerged is the unconsciousness, which marks both beginning and the end. So now, before Freud's discovery of the unconscious mind, science operated on the surface, and it is the conscious terminus of an unconscious process. So thank you. And now to indulge more into the world of dreams and science, I would like to hand over the charge of this presentation to my friend Disha Roy. Over to you, Disha.
I hope I'm audible. Thank you, Tanaya, and a very good evening to everyone present here. This is Disha Roy from 3rd semester Physics Honors Department of the Heritage College, Kolkata. Today, I am here to introduce you to the very emerging area of science, one that is still speculative but usually exciting. Certainly one that is rapidly growing, that is quantum biology. Now you might be wondering, where did the term biology come in a physics webinar? Now this is the point where the controversy lies. For the past 3 decades, neither the physicist wanted to mess up with biology, nor the neurologist wanted to understand quantum mechanics. So the area combining both of these fields is what quantum biology is all about. Let me tell you that quantum biology isn't new. It has been there around 1930s, but for the recent discoveries which has brought forward that in the biochemistry labs using spectroscopy, that certain mechanisms and the processes in the living cell can be explained with the helping hands of quantum mechanics. Nature itself utilizes the laws of quantum mechanics. Quantum biology is about looking for the non-trivial, counterintuitive ideas in quantum mechanics. We all know that quantum mechanics is very strange, yet wonderful and powerful theory of subatomic physics, which has been able to unlock every explanation at the molecular level in inanimate objects. Now, what quantum biology asks is whether the processes and the mechanisms of a living cell can be explained with the helping hands of quantum mechanics. So today, we are going to consider the living cell in our brain, that is, the neuron. You all know that the brain is a full compact model of about 100 billion neurons. Each neuron gets connected to each other through synapses, as you can see, and transmits neurochemical signals to the other cell. When we encounter a visual experience, the optic nerves carry the impulses to our brain, and which in turn ejects an emotion as reflex action to the visual stimuli. For example, you are craving for biryani, and unfortunately, you could not place the order and have to compromise with dal, chawal, and roti. I bet you would definitely dream of biryani. It happened with me last night, It's only because the desire that has been suppressed emerges out as dream. Quantum mechanics is a full world of probabilities and chances. For example, as you can see, there's a skater who is at the turning point of a road, and there's a tree in the middle. So he has got two chances. Either he can make a right turn or a left turn. And this completely depends upon the skater, which path he would choose. So as the particles can change their shapes randomly. Yes, this much weird quantum mechanics is. Now to connect the quantum world with the living world, there is a very beautiful phenomena of quantum consciousness, which evolved around 20 to 25 years ago and gained traction due to the proposition of two scientists, namely Roger Penrose and Hemroth. If you don't know about Roger Penrose, he was a great mathematical physicist and cosmologist. They teamed up to publish whether consciousness can be explained using quantum mechanics. The notion that within the brain, the neurons are proteins, microtubules, which can have different shapes at the same time, just like the particles in the quantum world have. They set a threshold which, when collapsed into the quantum field, leads to the switching on of consciousness. However, the best known phenomena in the quantum world is quantum tunneling, as you can see. On the left, the wave-like distribution of the quantum particles we can see on the screen. This wave has a certain probability to permeate through the wall, that is, disappear from one side and reappear on another side. I must tell you that quantum tunneling takes place all the time. In fact, the everyday sunshine is very much based upon the process of quantum tunneling. In the very same way, the particles in our brain, that is the neuron, form waves called brain waves, which transfer the minute particles of the cell to another cell using the same process of quantum tunneling. Now, the superposition of all the brain waves express themselves as consciousness, just like the pixels on a screen can express themselves as unity. However, these brain waves go far beyond our own neurons and get connected to other neurons in the environment. Hence, we are a global network of neurochemical reactions. As stated by the famous scientist Michio Kaku, particles have their antiparticles. So our neuron, being one such particle, it must have an antiparticle. Well, recent research have shown that certain unusual connection between two particles at a far distance apart are present. One such example that I would like to share with you all is about a European robin. Believe me, inside the robin's retina, there is a protein called cryptochrome, consisting a pair of electrons, which are quantum entangled. Now, quantum entanglement means two particles at a distance get connected somehow, which has been called by Einstein spooky action at a distance. Even Einstein hated this. Then it is so probable for us not to understand it. But I firmly believe that quantum biology is based upon pure science, and in the next decades, the world shall bring before you that quantum mechanics is the panacea to certain living processes of life. Thank you. Now, I would like to hand over the baton of our presentation to my teammate, Shruti Chakraborty. Over to you, Shruti.
Thank you, Disha. A very good evening, everybody. This is Shruti Chakraborty, a student of Physics Honors Department, third semester, the Heritage College. Since we have dived deeper into the dreaming interpretation, let me introduce you what dreams formally are. Dreams are primarily sensory experience, mostly visual, but occasionally involving other sensory modalities too. More or less, 5 stages of sleep have been identified in human beings, but for our purposes, we will be concerned only with 2 stages of sleep, that is REM, rapid eye movement, and non-REM period. REM is linked when we experience the deepest stage of our sleep, characterized by fast irregular brainwave activity. That is to say, our brain is in an accelerated state, as well measured by an instrument called electroencephalogram or EEG, as you can see on the slide, by its electrophysiological indices. Now, you might have heard the name of the famous Austrian neurologist Sigmund Freud, who focused on his famous research work interpretation of dreams with the very fundamental principle of mind, that is, unconscious events are not observable. And what his inner will was, he tried to link psychoanalysis with science. And to be very frank, there is only one principle in all science, that is, there are certain events that cannot be observed, and that is the principle of quantum wave function. Now let me tell you, the famous scientist Louis de Broglie talked of matter, that is, they are supposed to have a wave particle duality. And the very fundamental equation of quantum mechanics propounded by Max Planck, that is E equals hf, where E stands for energy of photon, H for Planck's constant, and F for frequency. And the bizarre thing lies here that this fundamental principle can be related with our brain consciousness too.
where E is replaced by C, and the equation becomes C equals HF, where H stands for Planck constant, F for R frequency, and C for R consciousness. Now, as I stated, every matter has a wave-particle duality. We are matters too. Yeah, though we are living waves, but we're part of the solar system, and we have our unique waves too. And these waves can be completely determined and demonstrated by specific functions called wave functions, which hold each and every property of the characteristic waves. A wave function is a superposition of all the possibilities, and observing them at a time can only infer a single probability or possibility. Observing the same function over and over again will eventually let us sample the full range of possibilities. Everything that we observe arises out of the possibility of the wave function. Now let me explain you simply. Suppose you're being asked by your friend to play football with him. Now what are the possibilities? That's how you respond to his proposal. You either accept it or just decline it. But suppose it's a rainy day and you are thinking that not to play football or just to sit back at your home and just to listen amazing music. But ultimately, you're opting to play football with your friends. But what about the lost chance of playing music? Is it really lost? Well, scientists tell that these so lost chances might be happening with us in our counterparts or so-called parallel worlds as stated in the many worlds interpretation propounded by Everett. And hence, the process of consciousness arising out of the unconscious is the very same process as the process of observation of the wave function. And it leads to the inescapable conclusion that our unconscious is the wave function and consciousness is what we call reality. And hence, our dream sleep has its unique wave function too. And it's got really a very fancy name that is PGO or pontine geniculate occipital waves, which are originating as neural connections and propagating towards the specific parts that is thalamus and neocortex. And these waves are having high amplitude and frequency. That is, they are in an accelerated state. And the turning point of the story lies here that Albert Einstein, in his famous theory of relativity, spoke of accelerated frames of references, where they are supposed to experience the phenomena of time dilation and length contraction. That is, the space and time comes closer to each other than what they in reality are. And interestingly, our dream sleep wave functions are in an accelerated state too. And they are also likely to experience this phenomena of the shrinking of space and time. Now, the space and time not only consists of we as a single entity, but other observers and their conscious minds with their wave functions too are there. And maybe through our dreams, they are coming closer to each other than what they really could have been done. And in coordination, they could really produce an alternative reality, maybe through the medium of dreams. And I must say, as a coupling of the Copenhagen with the many worlds interpretation, dream consciousness might get entangled with other observers and their conscious minds too. Now, what this entanglement is, quantum entanglement, is a bizarre phenomenon in quantum physics, which talks of two particles so inextricably connected that a change in one immediately brings about a complementary change in another. And this is of extensive use nowadays, and it's really providing us with cutting-edge, cool technologies such as quantum computing, quantum cryptography, and so many, as you can see on the slides. So, as clear by now, dreams are nothing but the propagation of specific quantized brain waves, which, just as any other waves, should hold too the property of interfering or getting entangled with other conscious minds' waves under certain conditions and might produce an alternative reality. Hence, probabilities are there that dreams might be an interconnection between conscious minds and so-called parallel worlds. And groundbreaking information lies here that brain-to-brain connections without any so-called sophisticated devices have been made possible many a times, and one such had been possible by the researchers of Washington in 2014. It was not that complex as it's shown on the screen, but it was not that easy too. Hence, it suggests that brain-to-brain connections could be made possible, though with complicated devices in our consciousness, but through our unconscious state of bliss, maybe no medium is necessary, and our waves are getting enough of that accelerated chances to come closure and to produce another reality. Well, we hope we have been able to connect with you in our humble attempt to bring forward something which talks of eternal connection, the best in foolproof scientific framework. We welcome any comments or suggestions regarding our presentation. And lastly, a many thanks to our friend Uncle Bo for being our technical help and presenting today's slide. Thank you very much, everyone. Thank you.
And with that, we are done with our part for today's evening.
Thank you so much.
So begins the question hour.
So I can see a lot of questions in the chat box, and since we are running short on time, we cannot entertain all the questions. So I can take only one question. I'll take that from Jia Sharma. Do we have a wave nature too, and why don't we feel it? So can we answer that?
Sorry. Well, I would like to answer your question. Yeah, as I suggested that Deep Roy in his famous equations talked of that matter are bound to have their wave and particle duality nature. We are matter too, because our neurons, what are they? The neurons are matter too, and you know what the neural connections are? They are nothing but the specific electric pulses which are generating due to the flow of specific ions, that is charged ions, due to the expression of several emotions. So this is the charges that are vibrating and they are generating waves, and these waves are there. We can't feel it, but it's well proven by the instrument that I just mentioned, electroencephalogram. And these waves play important role in our life too. Yeah, we can't feel it, but these are well proven. And discussed. Thank you very much.
Thank you so much. That was an amazing presentation. So who could have thought that something like quantum physics can explain dreams? Speaking of dreams, did you know that if you don't let a person sleep, then it is more probable that he will experience dreams? And what's more to that is it is not a simple guess, it can be explained by quantum physics. So a few minutes earlier, you got to see some fabulous facts about gravitation, dashing past dreams, and now about dreams. And all of these are explained and unified by a single subject, that is physics. Well, if you're not already surprised by the rich, vivid, and vast diversity of physics by now, prepare yourselves because the next presentation is going to show you exactly how many seemingly different laws of nature are so similar to each other. Please welcome Team Newton, who are going to take us through an absolutely thrilling journey connecting the different interesting aspects and wonders of physics.
Very good evening, everybody. Today we are here to make a shift in your perception of what physics is, which is mostly difficult and inaccessible. It's about the greatest of the great scientists like Newton, who discovered gravity after an apple fell on his head, or Galileo, who was just watching the chandelier in a church and came up with his time period constant concept, and Archimedes, who came up with his principle while he was just casually taking a bath. And as if all of them just came together to increase our syllabus. But is physics just about this? We'll find that out today. What you are seeing in your screen right now is our current perception of what physics is. We have quantum mechanics at the bottom and cosmology at the top. And the large gap that you are seeing in between, no, it does not consist of Modi ji. Don't look at him, look at his cycle. So today, we'll mostly emphasize on this large gap in between, which consists of things that you and me do on a daily basis. You will find out for yourself that the laws that govern these things are actually the same laws that are applied in astrophysics and particle physics. We find what keeps you seated in your chair, in fact, right now, governs the movements of the planets as gravity. That light is the same phenomenon as electricity and magnetism, and that space and time are the same thing. So basically, through physics, we create these models or patterns that define how our nature works. These are our natural laws, which are written down as mathematical formulae with explicitly defined terms. These are the laws that specify the relationship between forces and matter that govern and predict the workings of our physical world.
Okay, so when I think of an easy breakfast, easy because I don't know much to cook. The first thing that comes to mind is bread and eggs, usually hard boiled because that is even easier. Now, being a student of physics, I love performing experiments. So what I did was, I took a raw egg and a hard boiled egg and started spinning both of them. After a few seconds, when I stopped them, the hard boiled egg comes and then comes to rest. Now let's see what happened. When I stopped the raw egg, I just stopped the shell, but the rotating liquid inside made it. Why did this happen? Okay, this is a very, very simple experiment which all of you can perform in your respective kitchens. Just make sure not to break any eggs. Now, this was nothing but the simple demonstration of the law of conservation of angular momentum, which basically says that if you set something spinning about a fixed axis, it will keep on spinning until and unless you do something to stop it. So that is angular momentum in action, ladies and gentlemen. What is angular momentum? Angular momentum is the quantity of rotation of a body, which is the product of its moment of inertia and angular velocity. This is a quantity that is conserved when there are no external torques acting. The more massive and faster moving an object, the greater is the magnitude of momentum. Now let us look into an interesting toy, which was the investment of some of the greatest minds of physics, a gyroscope. What is a gyroscope? A gyroscope is a device consisting of a wheel or a disc mounted so that it can spin rapidly about an axis, which is itself free to alter in any direction. Did you notice a very interesting phenomena in it? Its axis of rotation did not change, even after tilting the board. That's what makes it special and even defines a gyroscope. That's what makes it special and even defines a gyroscope. So in case of rotation, when we apply force in one direction perpendicular to the radius, joining that point with its axis, a quantity called torque is generated. Now, the angular momentum points in the same direction as that of the torque, in this case, towards the axis of rotation, which helps it spinning further and further. The orientation of the axis is not affected by the tilting, so gyroscopes can be used in navigation systems, automatic pilots, and stabilizers, which is clearly depicted in the video. Now, I'm sure almost all of you have come across games like Subway Surfers and Temple Run 2, and the most hyped game, PUBG. When you tilt the screen, the phone can sense it and automatically changes the player's path, right? Guess what's making that happen? A more sophisticated form of the same gyroscope which we just discussed. This helps the mobile players with the lateral and up and down movement without using their fingers to move the players on the screen manually. So the game uses gyroscopic sensors which optimizes the screen's orientation with the mobile's physical movement. Isn't it a fun concept to play around with? Now let us see how this simple gyroscopic motion can be used in a more advanced device. And those some wonderful pictures. It has been collected by a space telescope called Hubble, which has been up there for the last 30 years. It was named after an American scientist, Edwin Hubble, who proved the expansion of our universe. Isn't it fascinating how so many laws of physics works inside one single device? Today, we will discuss how angular momentum helps it observing a star or a galaxy while it rotates around the Earth.
Okay, so previously the mechanism used to control the movement of the telescope around the Earth was mainly based on Newton's third law, which states that every action has an equal and opposite reaction. This system involves propellants, which are basically booster rockets, which uses the same principle, that is, it releases the gas in one direction, which provides the telescope a reaction in the other direction. But we don't use such course correction mechanism. I mean, there are finer and more accurate ways of dealing with such kind of steering problem. And also the fuel might run out too soon, which will eventually need refueling. And that's where we use the reaction wheels and gyroscope in Hubble Space Telescope. It works in the sense that their axis of the rotation keep pointing in one direction. And if the telescope starts to move while the gyroscope is spinning, the sensors present in the telescope will feel a motion, and that's a diagnostic that tells that the craft is drifting from its original point of observation. Now, the telescope has these black bars that you can notice here, and these are called magnetic torquer bars. And they're kind of neat because they use the fact that they are operating in Earth's magnetic field, and they can sense the magnetic field. And they're basically electromagnets that can be switched on and off, which provides a magnetic torque perpendicular to the magnetic field of the Earth, aligning the telescope and helping it steer around the orbit. So we have talked about how the Hubble Space Telescope points and steers around in the orbit. In order to spin around its own axis, there are these 4 flywheels that you can see, and these are known as the reaction wheels, and they can be spun up or spun down by an electric motor. And again, it's all just simple conservation of angular momentum. If you spin the reaction wheels in one side, then the telescope has to move in the other side to compensate everything. This is how Hubble was able to take those wandering images of our cosmos. The picture you are looking at right now is known as Hubble's deep field, and it's a very small patch in our sky, but it still consists billions and billions of galaxies and stars, if not trillions.
Okay, so Marvel fans in the house, I hope you can recognize him. Yeah, that's indeed Robert Downey Jr., aka the Iron Man, and yes, we love him 3000. Now in the screen, you're seeing, we can see him standing with a projection of the city's map, probably planning for its protection. Now, wouldn't it be cool if we have the same technology that we see in our all-time favorite sci-fi movies? I mean, the whole city could be viewed from anywhere. Now, with the prevailing conditions of Corona, I wouldn't be surprised that if by 2021, we need to fight someone like Thanos or a giant lizard from the Spider-Man. And I think holograms could be of great help at that time. Now, it is up to you to decide whether we can recreate the same table which you are seeing now, but it has already been created by engineers back in 2017 using holograms. So that's our next topic, ladies and gentlemen, holograms. Now, we know that light behaves in a very strange way. It behaves both as a particle and as a wave, as discussed by the previous groups. Now, this has been the main topic of debate for hundreds and hundreds of years, with a team including Sir Isaac Newton on one side, up against a team including Christian Huygens. But it was only in the 19th century did the wave nature get more recognition due to the beautiful experiments of interference and diffraction. Now, these experiments paved the way for a whole new paradigm of physics. So now, what is interference and diffraction? So, as you can see, interference is a process in which two waves superpose to produce a pattern of alternate dark and bright patches. Now, diffraction is also the same process which produces the same kind of pattern, but it's a bit different, and its formation is also a bit different. Now, it involves the bending of light around an opaque object and combination of different kind of phases. Now, what's the difference between interference and diffraction? Now, as you can see on the left side of your screen, the alternate dark and bright patches which are formed are mostly of equal width in case of interference. Whereas in case of diffraction, you might see that the central width is of the largest size, whereas the others are of decreasing width. So now these experiments explain the fundamental wave nature of our light, which can be used to produce some of the coolest objects in our daily life. Holograms are one such example. So now, what is a hologram? Okay, the hologram, actually the word hologram originates from the Greek words holos, meaning complete, and graphos, meaning writing. Thus, it is the technique to record the complete picture of an object. Now, it actually encodes a three-dimensional picture, which basically provides you the complete information about an object. So at the right side of your screen, you can see a picture of a dove, which you might have seen in every credit or debit cards. Now, this is actually an hologram, and this has a very important utility in security systems. Now, how it's important? It's like that, it works like that. The thing is that it appears three-dimensional if it's really an hologram, but if it doesn't, we can identify it as to be a fraud one. So yeah, now you can see that it has a very great utility in taking out money from ATM machines, which is very much important, guys. Yeah. So the credit for the invention of this technique or the holography goes to Sir Denis Gabor, who was an Hungarian physicist, and he was awarded the Nobel Prize in Physics in 1971 for the same invention. So now let's move on to how an hologram is actually created. So it consists of two processes, the first one being recording and the second one being reconstruction. Now let's discuss the recording. Okay, in recording, we can see there's a laser beam from a laser source which is incident on a beam splitter, which splits the beam into two parts. The first one, after being splitted, strikes the photographic plate, and this is known as the reference beam. While the second one, after suffering a deflection from the main object, strikes the photographic plate, and this is the object beam. Now, when both of these beams superpose, they produce a pattern, interference pattern, which we learned about a few moments ago. And they form a pattern of alternate dark and bright fringes. And this is what is recorded in the photographic plate. Now, after this, we go on to the process of reconstruction.
Reconstruction. So reconstruction is basically dependent on two processes. One is interference, another one is diffraction, which has been previously explained by my friend Shottujit. Now, after the interference pattern has been recorded in the holographic plate, it is illuminated by a laser beam, which is of course our reconstruction beam. Now, this holographic plate of ours acts as if it is made up of thousands or 2,000 slits, and in fact is called the grating element. Now, after the reconstruction beam passes through the holographic plate, each part of the beam gets diffracted first, and when they superpose later by the process of interference, they give us a virtual as well as a real image. Now, some of these diffracted rays appear to have diverged away, and when they are projected back together, they give us a virtual image. Now, this virtual image is our three-dimensional image and looks exactly like the object. Now, you all must be wondering that what exactly is the difference between photography and holography? Well, in order to understand this, let me introduce you to a very interesting concept, phase. Phase is basically a state in the recurring cycle of changes. To be in the same phase simply means to be in unison. Now, you all know that in photography, we get a two-dimensional image, right? And in holography, we are getting a 3D image. This is because of the fact that in holography, both the intensity as well as the phase of the light waves gets recorded. Whereas in photography, only the intensity of the light waves gets recorded. Now you know how your all-time favorite blockbuster movies like Avatar, Star Wars, and even Iron Man was created. Imagine a world without holograms. It would be a little hollow, wouldn't it? I'm sure it definitely would be. So with this, we come to an end of our presentation. Now you know how everything that you do in your daily life, right from waking up and having your breakfast, playing games in your mobile phone, till ordering your food with the help of your credit card, includes physics. Thank you.
Thank you so much, Team Newton. So we have a question from Anushka Goswami. How can you say that angular momentum and torque are in the same direction? Is this always true? If not, then please provide an example. So can you enlighten us with that?
Well, torque is perpendicular to the plane formed by, R and F, which is in the direction. So basically, like I already discussed, that torque and angular momentum, they have to act in the same direction. It has been proven there's nothing which goes beyond it. Okay, so now when like the otherwise can happen only if we try to stop the earth, okay, which is not possible. So I'll give you an instance. The only way the earth would stop rotating is by losing angular momentum, right? The earth is losing its angular momentum so slowly that it would take millions of years for it to stop its rotation naturally. So yeah, this is true that angular momentum and torque always act in the same direction. So far, so forth, there's nothing that proves that they act in the opposite direction. I hope I could answer your question.
Thank you so much. We have another question. This is from Sanjukta Datta. So can you explain what does hologram have in store for us in future? So do we have an answer for that?
Yes, Sanjukta. So basically, in the near future, you will be able to see something like the holographic projections, which could be used in the meetings and conferences. So holographic projections could also be used in marketing department, maybe to explain the 3D concept of something like a car. So that could obviously improve the view and the understanding of the audience as well as the training session. Also, holographic teleprocessing is a thing which is being made, being used by the Microsoft HoloLens. We have produced something like that previously, which uses the concept of holographic teleprocessing to basically make a smart glass through which you can display images and information. Also, holographic telepresence is something which will be a thing in the near future, where you can be present inside your home and be present at a meeting in the same time, which is miles away. Also, scientists are claiming that we can be 3D projections of a 2D of the information which is stored in a 2D surface that maybe surrounds us. They're also saying that suppose like in the black hole, it is obvious that if you throw something, it gets lost, right? But the 2D information, they are saying that the 2D information is smeared on the surface. So basically the object is present in both the places. A 3D version of it gets lost inside the black hole, but the 2D information gets smeared on the surface. So basically we can reconstruct our object with the help of the 2D information. It's basically acting like a computer or a hologram which stores the information and the data. So with this, we can basically get an idea of what's happening inside the black hole by only referring to the information that we have from outside. And something which is really mind-blowing is that since the space inside the black hole plays with the same rules as that outside the black hole, so scientists are basically claiming that we all can be also 3D projections of the 2D information which is kept in a distance which surrounds us. So this is the thing. That's it. Thank you for your question.
So that was the last presentation, and it was indeed a marvelous one. So as we come to an end of this seminar, I want you to imagine a much improved world where our civilization has reached its pinnacle. A world without the perils of global warming and immense energy at our disposal, where we can travel with the speed of light and reach other planets in the solar system and beyond in no time. From a single planet civilization, we might become a multi-planetary civilization. Maybe in a few thousand years, using the advanced technologies of physics like nanobots, human lifespan might be increased to near immortality. Maybe we'll be able to turn the fantasy of telepathy into reality. We might have flying cars, time machines, and everything that you come across in science fiction books. It is beyond our imagination how the world might be in a few hundred years. Sure, must hold a lot of treasures for us to cherish. Now, this seminar would not have been possible without the guidance of our mentors, Vishal Khan, Protvar Patro, and Manush Dokra. So, Vishal, if you would like to share something about your experience of working with us.
মাইক্রোফোনটা অন করো।
Sorry for the inconvenience. That was enough of physics, right? So, I have been called by Samriddhi to speak a few words about our experience with all of them, and I am very glad to speak on behalf of Prokta and Manoj. So, first of all, I would like to thank COVID-19 for this immense and amazing opportunity. Before all of these, our lifestyle was eat, sleep, and repeat. Yeah, and such a boring monotonous life to lead for about 4 to 5 months. So one fine morning, our HOD, Madhu ma'am, called us and gave us this wonderful opportunity to mentor the second year students. So I suddenly said a yes. At last I got a job so that my brain does not rot in this lockdown after all. So I joined the mentor team with a very casual note, and I realized that I am just 21, not an 81 guy. So the experience was really wonderful for us and a very new thing for us too, because we have never ever mentored anyone in our life before. Sometimes we get glimpse of our teachers, how they deal with us throughout the year. And the biggest truth I want to tell you that everything they did was theirs, and all the credit goes to them. But actually, we also learned something from them. New ideas, new physics, new explanations, new theory, and many more, which we haven't even heard of. So, at last, we can conclude that there's no seniors and no juniors. It's us, the physicists of the heritage. Thank you. Signing off.
Thank you so much. So it is a great privilege to propose the vote of thanks to all the dignitaries present here. On behalf of the Heritage College, I would like to thank the entire fraternity of the Kalyan Bharati Trust for giving us the opportunity to organize this webinar. The webinar wouldn't have been possible without the guidance of our Executive Director, Mr. Pradeep Roy, our Chief Executive Director, Mr. Pradeep Kumar Agarwal, and Student Coordinator, Mr. Clayton M. Moses. From the core of my heart, I would like to thank our beloved principal, Dr. Pushpita Ranjan Bhattacharya, and Joint Registrar, Kavita Shastri, for their constant guidance and support. My sincere thanks to Dr. Madhuprata Bhattacharya, HOD Physics, and all faculties and staffs for being here as always. Last but not the least, I would like to thank all the viewers who gave their important time and participated to make this event a great success. Thank you so much. Good night.
Samriddhi, before calling it a day, I like to thank you because you have conducted the entire program in such a manner which simply has won my heart. I especially, there is a desire to express my heartfelt thanks to you, and I like to bless you. And above all, the mentors have made it into a reality in such a way, I should say, that the speakers spoke so fluently. I am not a student of physics, but what I realize is very simple, that the students could realize what their mentors are expecting from them and their teachers are expecting from them. So no word is sufficient to appreciate all the speakers today. I like to congratulate them with the expectation that in the near future your department will again organize such seminars. Thank you. Thank you all.
Thank you, sir. Thank you all for coming. Thanks a lot for your support. Thank you very much. Now I request you all, please leave the meeting room. Our program is at end. Thank you so much.